Well, back in 1994, Denis Weir, who is a professor in physics in the School of Physics in Trinity, and his PhD student at the time, Weaire-Phelan, they addressed the problem of what is the ideal structure of foam. And this goes back to a problem posed by Lord Kelvin in the 19th century. And Dennis and Robert looked at this again, and using computer simulations, found quickly that there is an alternative structure available, which is better than Kelvin's structure. Now, this is a computer simulation, and ever since, people here in our group and in other laboratories all over the world have tried to actually make that structure using real soap bubbles. Because you can make the Kelvin structure, you think you should make the Weaire-Phelan structure as well. But that proved very tricky, and nobody had ever succeeded to date. And this has to do with certain boundary conditions that need to be met. The Kelvin structure you can make against a flat wall, and this Weaire-Phelan structure you can't do. Then about 6 or 7 months ago, I received an email from an Italian researcher whom I had met before, and I knew he was working on that problem as well. And he emailed me and he said, "Stefan, I have an idea how to make that structure using a template. And I'd like to do this in your lab because you have the expertise here and the know-how how to do these things." So I invited him over, and I was in the lucky position to have some funding from SFI to do this. And he was here for 2 months, and it was a very successful visit. Now, why was it successful? We were able, first of all, we were able to work together with Ken Bracke, who performed further computer simulations for us. And then he worked out the ideal surface that is needed to trigger the formation of that structure. Now, how does one make such a structure? Well, we create bubbles, ordinary soap bubbles, and then we make a little box, which is the template, and we fill up that template with these bubbles. Now, there you might think, well, why haven't you done that earlier? But it's only now that we are able to make such detailed structured templates with the help of our colleagues in the Trinity Nanoscience Institute in Cran. So there you can see that it's really the new technology which allowed us to make progress in physics. So quite quickly when we went to the lab and we had our templates made, we looked at the samples and we could say, and in particular Ruggiero, because he spent so much time looking at these things, well, this is the Weaire-Phelan structure. And we were able to produce it many times, produced a number of photographs using bubbles which are a few millimeters in diameter or slightly larger, and using samples of up to 1,500 bubbles. So not only the bubbles in contact with the surface are regularly arranged, that would be what expected, but we had up to 6 layers of bubbles which form, so they're away from the surface, away from the template, so we can really say we created a bulk Weaire-Phelan structure. But you might also wonder, what can one do with such a thing? I'm very much into sort of the principles of physics, so my first thing would be, there is a nice mathematical problem and we solved it. It's sort of really a theoretical problem that we looked at and we managed to make. And for me, this is already is a big success story. But I'm aware that one can do other things with it. And namely, one can solidify such samples. It's hard to do, but we've done something like this in the past. So you could have then a solid sample. And with a very regular, ordered